Welcome back to some of the most exciting YouTube content that you have ever watched. Today, we're talking about scheduled jobs. This is probably going to be one of, again, the fundamental pillars of your rapid application that you're trying to achieve during the hackathon. There's lots of different jobs that it could be occurring. But now, who is this video targeted to? So if you're a senior engineer and you're like, look, I've used Quartz, I've used Coravel or Hangfire, hang around for a little bit because I'm going to be dropping some what I'll call wisdom. You can demote it to opinion if you want, but like why you should build things in a particular way. This is after obviously putting, hundreds of financial institution installations and supporting them, things that you've seen out in or things I've seen out in the wild occur. Um, and This architecture really costs you no extra time to do. And I think it provides a ton of extra flexibility in a lot of different ways. So hang with me. But once we get to code, we're going to be going over a lot of code in this particular video um, of how to set this up. And so if at that point you're like, nope, I know my tools, I know what I want to use, feel free to bounce. This will, as when we get to code, this will be for more of an introduction of how to set up a Windows service using Top Shelf and Quartz. Okay, so the topics were going to be of why do we want to use a Windows service? Why are we going to use Top Shelf to create that Windows service versus like a service template from Visual Studio? And then we're going to get into that code that I talked about, how to put it all together. Okay, so what is a Windows service? If you are not familiar with what a Windows service is, 30 seconds. It's the operating system or the server has registered executables that it is told to turn on at particular timings when the server starts. Administrators can control this by disabling them or enabling them. But here's the real key part of it. That executable starts and it stops. That's all you really need to know about it as we then go and kind of create then our Windows service ourselves. Okay. So why are we going to build a Windows service to host our scheduled jobs? You can read a lot of documentation about like Hangfire or Coravel getting jammed directly into your web application. And that's fine. For a hackathon, for a proof of concept, that's probably just fine. However, again, we can do better and I think actually expedite software development and debugging during the hackathon if we just do it a little bit differently. But why a Windows service? And that is because, in short, it just makes the system or you're offering even more production ready than it actually is. And why does it become more production ready if we do that? One word: isolation. By separating the web application and this actual job runner, this Windows service apart, that isolation and flexibility then gives us a ton of things when things are actually installed out into the wild. One of them is security. There are a lot of, and I could literally ramble like 24 reasons why between security and performance of why this is the case. But when your scheduled tasks take the same memory space and take the same executable space as your web server, you really limit it and really start adding a lot of different signals to the operating system. So one of them is security. There's a lot of endpoint detection systems like Carbon Black or Cisco Duo endpoint detection, where if that task is doing some real heavy lifting, then all of a sudden and now I'm kind of bleeding into performance, you are now making the container, the W3C IIS process, taking in like way more threads. It's taking up way more CPU, and different antivirus softwares and things of that nature will actually start throttling or start shutting down those particular things. So you may have a reason why you're like, look, I have so many jobs running that my IIS app pool, like it's not even like taking in web requests anymore. I've seen that. I've seen throttling occur where web requests aren't coming in because the jobs are being so piggish. I've seen from a scalability standpoint needing to create like a bank of like 6 or 8 Windows services working in conjunction to do some real high CPU load stuff. And the web application was just a real simple little shim. Um, I've seen from a security perspective needing to authorize the IIS app pool different than the Windows service. They wanted 2 different security contexts. I've seen the IIS app pool. Here's kind of going from a different direction. I've seen the IIS app pool set to be configured to tear itself down after 20 minutes of no web requests. And that killed and severed all the jobs that were running. So there's tons of different reasons why you want these things separated. Okay. Um, but why Top Shelf? So what is Top Shelf? So Top Shelf is, and let me try to get to here. So Top Shelf is an open source project, and it is still used in conjunction a lot today. So effectively, this is what Top Shelf's play is they're like creating Windows services using Visual Studio normally is a huge pain in the butt. Yeah, you can just right click, say new project, and go bing, bang, bong. But the problem is that debugging those Windows services when you are actually in development can be extremely problematic. At least in the past, I haven't had a lot of current experience in like the .NET 9 and kind of where VS Code is evolving and all that stuff. But if you just hit F5, like it doesn't really hit your breakpoints. I've seen situations where, like, let's hypothetically say that I'm working for a company, let's say CrowdStrike, kind of timely. Let's say I'm working for CrowdStrike. I have CrowdStrike running on my machine, and I am actually developing the next version of that thing. I hit F5. Now there's this contention between the service that's installed on my machine and my debugging environment. So Top Shelf helps alleviate that. They're like, look, we're going to keep it simple. You create a console application, you add Top Shelf as a dependency, and when it comes time to debug, I'm just a console application. And when it comes time to install, I'm a Windows service. And it takes care of all of that interop and system goo just totally magically for you. It is a super slick thing. So, going back to Top Shelf, why Top Shelf? For development purposes, makes debugging significantly faster and can increase your dev cycles. It also can allow you then within Visual Studio to say, I want to debug both my Windows service and my web application at the same time. I want to turn off my job runner at this moment and just work on my web application, or vice versa. I find that it increases your iteration cycles significantly. But for DevOps, then also packaging those Windows services can be a real pain in the butt. Installing them using sc.exe is a big pain in the butt. And if you don't know what I'm talking about, just be thankful that you've not drug into that drama. Because I'm also talking about sysops, about installing or uninstalling. Top Shelf gives you some really nice command line arguments to do all of that for you without having to get drawn into the mud of what historical Windows Service Management is all about. Okay, so we'll go back to the Top Shelf page. So here is the GitHub. If you go up to Top Shelf Project, this link is now dead. The documentation for Top Shelf is now out at readthedocs.io. But again, you really don't need, for the purpose of the hackathon, to really dive in to understand this stuff, because you're just going to be hitting F5 to do your demo on stage anyways. But as it pertains to actual documentation of how to install your product and things of that nature, literally is as simple as your exe space install at the command line or space uninstall. It just really, really simplifies everything. Okay, so I'm going to open up some code now. Okay, so we have a couple of pieces that we need to kind of talk through as it pertains to building um, Windows services. Now, this is a submission that my team did in the 2023 hackathon. So this isn't a YouTube like start from scratch tutorial. That's not kind of my style, anyways. Um, I'm going to just show you the code and I'm going to talk you through it and walk you through it. Now, this is boilerplate code. This is do not feel like if you're stealing this particular code that you some type of cheating at the hackathon or anything of that nature. It's going to make you cite your resources. This is really boilerplate code because the real workhorse of it is what you're doing in your jobs, right? That's what creates the business value. So what you effectively do is within your solution, you create a console application. That console application is literally at one moment just going to have this static void main. That's going to be literally it in that whole project. What you're going to then is you're going to bring in the dependency, the NuGet dependency top shelf. What top shelf does again is it wraps that application, and then to start invoking top shelf, you use this nomenclature of host factory. You register the services that you want to be running. But this is also the cool thing about Top Shelf then is you can then kind of configure the Windows service just as if you were to right click in the services console and say, properties. You want it to run as local administrator or excuse me, as local system in this case. You want to set its name up in its description and all of that stuff. You can define all of that in code and control it for when it's installed. Okay, but then so that is really all you have to do to implement Top Shelf so that you can have this developer experience of being able to debug multiple projects at one time. I mean, just if you were to go up to where is it? Configure startup projects. And you can see here, I can now debug my web service, my web application and my job runner, my Windows service at the same time as if I have this fully installed on a server. Pretty cool stuff. Okay, so now where does Quartz come in? Now, you have a lot of different options at your fingertips. And from this one, I have a little bit less skin in the game of what you choose. I'm familiar with Quartz. I've been using it for years. I know its ins and outs, its strengths and its weaknesses, but you have lots of different options. So here is quartzscheduler.net. This is the homepage for quartz.net. It's a very mature and old port of Java's Quartz scheduler. Hangfire is a newer version of this like scheduled job ecosystem that a lot of people have started to adopt and has become very solid pick. And Coravel is kind of a new entry that a lot of people are starting to snag onto and really, really like. I will show you how to configure Quartz such that if you decide to use Quartz, you sure can. But if this is a weekend for learning. If you want to look at something different for your own education, you sure can. Okay, so back to code. Okay, so how do we do this? So when I was talking about services saying start and stop, that's really critical. Okay, because we have to write just a touch of extra code that kind of wraps and adapters Quartz such that it can then orchestrate with when that Windows service is starting and stopping. When the Windows service starts and stops, what should Quartz do as a job scheduler? Okay. So in order to do that, we have to then say, now this is a top shelf registration saying one of the services I want you to run is this Quartz service controller. Okay. And this is our own class. Okay. So we go to Quartz service controller. You can see it right down here in the solution. And it's super, super stupid. It's super simple. Okay. Our constructor takes in a create schedule function. That is, when I want to initialize, what do? I don't want to put that here. I guess you could put it here. I mean, you could put it in this class. I've decided not to, but you could. But what do I want you to do? And now, really, all that we're doing or defining is what do I do when I start? What do I do when I stop? That's it. So if I stop, if I have a scheduler, I shut it down and I don't wait for the jobs to complete. I just kill them. Okay, when I start, I ensure that I'm stopped. I create a brand new controller and I return true. That's it. Like we're really, again, we're just adaptering like how do we want to build and destroy the Quartz job scheduler within this. After this, we just then continue registering what we want. Now this method right here, this function is what's getting passed in and is called the create schedule func in that other thing. You could put all of this in that other thing. But you still have to kind of have it abstracted as an initialize method, because what happens if the Windows service starts and stops numerous times? So here we're getting a scheduler from the scheduler factory from Quartz. Here is a little helper method so that we don't have to rewrite these lines of code over and over again. But effectively, we're saying, hey, I want to schedule this job with this cron expression. If you don't know what cron expressions are, you can look them up very simply, but it's just very simply a way to define like frequencies. Do I want it every minute, every second? Do I want it on midnight, on Mondays? You know, what however you want it. Pro tip, if you're using Quartz, here's one gotcha. Quartz cron expressions are different than general expressions, but not by much. So if you go on the web and say, give me a cron, or chat GPT or whatever, and say, give me a cron expression for every other minute, it's going to be wrong for Quartz, because Quartz gives you one extra digit for additional precision. So with Quartz, you can actually get more precise than the original, like Linux Quartz, what's the word I'm looking for? Definition or standard. So, so you can go out to quartz.net and it's very clearly documented out on that website. But effectively, all you're saying then is, I want to schedule these jobs to occur on these frequencies, and I want you to start. That's it. So this, though, is where the real work is done. All that other code that I just showed you, if you were to write that, it's just boilerplate, get going code. What you do then is, let's hypothetically go back to update member table job. And this is how you create a job. You inherit from iJob, which is a Quartz interface. iJob demands that you implement a execute task. Okay. So this is the entry point that it will call when the timing of that cron expression occurs. And really, you do your work, and then you return task from result 0. If you're familiar with async, AO8 stuff, like you should understand or know what's going on here. If you don't, just return task dot from result 0. And then this disallow concurrent execution is an optional attribute that says, if I already got one of these running, don't invoke another one in parallel. Because let's say you say, I want to fire this every second. What will happen if it takes 3 seconds to finish? Well, eventually you'll end up with a lot of piled up jobs that need to execute that might even be crashing against each other. So it's just a good optional attribute to put on there. But effectively, that's it. That's all you need to do to set up a working, functional, production-ready Windows service using a console application, Top Shelf, and Quartz.net. Go ahead, create your jobs. That's where the real meat of your business logic should go. Easy peasy squeeze the lemon.